move on to Module 4.2, this is where we start to calculate probabilities for what we call compound events. Events where there are more than one event occurring at a time, right? And another way we have to also analyze these events, right? Compound events happening at more than a single event, right? Is if they are independent and mutually exclusive, right? Does one event affect the other in some way? So something to think about as we proceed with this section. So here's an example again of compound events. Let's say you're going to a bakery, you're going to order a cupcake by choosing one of three flavors, right? There's your three flavors. And then you're going to choose small, medium, or large. So think about the sample space, right? Since there are two events that are occurring here, right? You're going to choose a flavor and then choose a side. So there are multiple ways to try to think about what this sample space is. You have tree diagrams that kind of look like branches and stuff. You have a matrix, right? You could just list out all the possibilities. But again, thinking about here are our options, what would happen? A chocolate with the small, chocolate small, medium, chocolate large, and so forth. So you get a sense of all the different possible outcomes. And in the end, you'll see there are 9 different possible outcomes, or some people may call combinations in our sample space. So we're not going to do a lot of this by hand, but this is just a visual of understanding how compound events are going to be different than our single events or outcomes. Now, when we have these conversations, we're going to be using the words and versus or, and or, right? So what is the difference between them? Well, we're going to say, what's the probability of event A or B, right? Or A or B is an outcome. That means that A, right, that the outcome happens is in A, or it could be in B, or it could actually be in both. And that would suffice for A or B. And so notice the sample spaces. A is 1, 2, 3, 4, 5. B is the outcomes 4, 5, 6, 7, 8, whatever those outcomes are, numbers, right? And then what's the sample space for A or B? It's all of the numbers from 1 through 8. One of these numbers would suffice to A or B happening. And then and is a different sample space. It means that both, right, have to be in A and B when we think about it as the outcomes. So the new sample space for A and B is 4 and 5 are the only two numbers that are in both A and B. So with that said, thinking about that language, here is A, right? The number is 4, 5, 6. Those are the outcomes, 4, 5, 6. B is the outcomes 1, 3, and 5. What's the probability, right, if you roll a dice, that you get that A or B happens? Well, when we think about A or B, so when you roll the dice, does A happen or does B happen, right? So A or has 3 outcomes, B has 3 outcomes, but 5 is in both A and B. So how many different outcomes are there in total? That's 5. So the probability of A or B happening, meaning you get an outcome in A or B, is 5 out of 6. And we use Venn diagrams to draw a picture of it, and you can see there's an overlap and there's 5 total. 2 is the number that's not part of any of those sample spaces. Another term we use for or is union. Okay, so that will come back to us. The union is another term we use for or. First is the probability of A and B happening. Probability of A and B means that the outcome has to be both in A and B, and the only one that is in both A and B is 5. So the probability of the event A and B happening, meaning that a number is in both A and B, is 1 out of 6. Because there's 6 total outcomes, there's only one that's in both of them, and the Venn diagram helps us see that again. We use the term intersection for and, because you can see it intersects. It's in both. Union is the joining of it, so the outcomes are within both circles. So important to keep in mind.